Hey, welcome back, fellow coders. It's me, the Web3 Idiot. Today, we are jumping back into our series on JavaScript arrays. In our first episode, we talked about different methods that you can call on these arrays. In episodes 2 through 7, we looked at some real problems and real-life implementation. And we're going to continue that on today with finding the intersection of two arrays. So what exactly does this question mean? Intersection means where both of these arrays come together, or the idea behind it is that these two arrays intersect at which elements. And the key takeaway here is that we're looking for elements that appear in both of these arrays. So let's say we're given 1, 3, 4, 5 as our first array, and our second array is 1, 4, 5, and 6. So our output, what would our output be? We look at 1, 1, they both appear. We have a 3, 3 does not appear over here, okay. 4, 4, good, we have to include 4. 5, 5, good. And 6 does not have a partner. So our output would be 1, 4, and 5. So basically, we want to look through this array and see if the element appears in the second array. And if it does, we output it here. Now there are 4 different approaches I came up with for a basic understanding of JavaScript arrays that we can implement in order to solve this. Now our first one would be a calling a ForEach method, and we would combine that with dot includes. And then we'd also combine that with a output array. So basically we look at, we can pick either one, it doesn't matter. So just for simplicity's sake, we would look at this array here, we call for each on it. So we do 1 and we take array 2, we say, does array 2 include this 1? Yes, it does. Then we push it to this output. Then we look at number 3 in this for each, and we do second array includes number 3. No, it does not, so we continue on. Next up, we have number 4 appears from this for each, and we say array 2 includes 4. Yes, it does. We push it to the output until we get to the end. So that is one approach. Our second approach is a little bit different, but a little bit similar as well, in which that we use a dot filter. So basically we are returning, we do filter, and we also use includes on this one as well. Filter plus includes. So here we go. Basically we do the same thing. We call a filter on this array, but we only give back or return an answer that includes elements in both arrays. Moving on to number 3, we are going to introduce something called a set, and we would do filter plus set, specifically the dot has. We'll talk about this in a bit. This will be our first introduction to sets. I will have another series on sets coming out later, but for now, just give you a brief introduction. And then our last one, we can do dot reduce plus includes. But I think we should go ahead and switch the order of these two. You'll see why in a second. Put it there. And yeah, let's move on to our time and space complexity. So basically what we have here is we have time complexity for all of these, which would mean specifically for 1, 2, and 3. So basically for each, that is a loop, and includes, that also loops through. So we have in, we could call this one an im over here. In plus im, or in times im. So for each in, we have to go through it im times to make sure it appears over here. Same thing with this one, filter. We look through all of these, and compare it to all of these. Same thing here, all of these compared to all of these. And number 4, we'll talk about that in a second. So this would be in, which is the value of, I guess, the total number of elements in the first array, and times m, which is the total number of elements in the second array. So those are for approaches 1 to 3. But for approach number 4, it is special because we're using this special thing called a set. So what a set does basically is it doesn't allow, I guess it wouldn't make you go through the second array every time. It's a direct call. So basically, to create a set, it takes m times. So that would be O of m. And then to look at each of these, this dot has an O of 1 time complexity. So each of these times 1 would just be n times 1. So this would just be n plus m. That would be our time complexity of this one here, which is better than the previous 3. That is why I put it down here on number 4. We gotta save the best for last. And then we're moving on to space complexity. We have for each, and it includes, but here is the main one. Here is the output array. The output array here. So basically, for the first one, we have O of n or m, depending on math min of n or m. So it is going to be the lesser of these two because the output set can never be larger than the smallest array, pretty much. Same thing with our filter here. This would also, the output would never exceed these. Moving down, number 3, pretty much the exact same thing, except for our last one here, because we are creating a set, this is actually for number 2, or number 4, we have O of m plus math.min of n or m. This m here represents the set that we are creating, which is another data structure. Yeah, so we're going to go ahead and jump into implementation. So let's go ahead and get started. Function. We'll call this one intersection. I don't want to have a uppercase intersection. And I'll call it for each. And we'll pass it array 1 and array 2. Pretty good, pretty straightforward. And remember, for the for each one, we have an output. So let output equal, and this will be the intersection elements. And then we have to pick either array 1 or array 2. And for simplicity's sake, we'll do array 1 dot for each. So we are looking at each element inside of this array. We will take it. We will say this number, pass it over here, and basically we are calling we're doing a bit of a function on it. So if array 2 dot includes num, then what do? We will output dot push our num. And yeah, that will do it for every single element in array 1. And it will look through array 2 for each element. And if it does exist, it will push it on to the output. So we will return our output. Let's drop down here. We'll go console.log intersection for each, and inside we'll pass it the arrays 1, 2, 3, 4. And over here we'll pass the second array, which will be 3, 4, 5, and 6. And what we should expect is an output of 3 and 4, because those are the two matching or intersecting elements of these two arrays. Let's run it, and we do get 3 and 4 over here. Very good. So basically, just to quickly run through it again, we take ForEach, we call ForEach on this method. We call the ForEach method on this array that extracts every element and then looks to see if it is inside of array 2, and if it is, it outputs it down here. We're going to keep moving on to number 2. Number 2 is our filter approach. So this one has significantly less code. So we can say function intersection, and we'll call this one filter. And inside we'll pass it array 1 and array 2. So this one, it's just one line of code actually. So we can do return, and we'll say array 1 dot filter. And what are we filtering? We want to make sure that everything that we return, not item, let's just call it num, just to be consistent. Everything that we return is inside of array 2. So remember, this is also another includes. And inside here, we'll pass this num. And yeah, this is just one line. Pretty simple, pretty straightforward. Nice combination of filter and include. We do not need to make another output. Yeah. So let's go ahead and test it. We'll do console.log. Inside, we'll pass this intersection filter, and we'll pass in 1, 2, 3, 4. And over here, we'll have 2, 4, 5, and 6. So we are expecting 2 and 4 to be our output. Let's run it. Over here, we get 2 and 4. Very good. So basically what this does is we have array 1. We're using filter. And we are taking the number from here. Make sure it is included over here. And if it is, we keep it. If it is not, it is taken away, pretty much. All right. Moving on to number 3, which is our reduce plus includes. So this is a bit longer, but function I can't spell today. Intersection, and this one is reduce. We have array 1, array 2. And what are we doing with this one? Basically, we will return array 1, and we'll call reduce function on it. We will have an accumulator, and we'll have the item. We'll have an accumulator, and the number that we are looking at, we will pass it over here, and we'll say if array 2. And we are also using includes, and we are looking to see if it includes this number. Then we will say the accumulator, which is what we're passing up, will be pushed the number. Pretty good. And after that, we will return the accumulator. All right, and then we also need to make sure that we start out with an empty array that we're passing. And yeah, that's pretty much it. So by the time it gets to the end, this returns it to here, which then returns it out. And let's go ahead and console this out. Console.log, and we'll say, what are we doing? Intersection reduce. And inside we'll pass it 4, 2, 3, 1. And then over here, we'll just say there's a intersection of 3, 7, 8, and 9. So the only intersecting element would be this 3 here. Let's go ahead and run it. What do we get? We get a 3. Okay, very good. So basically, let's run through this one more time. It is a simple reduce method. This here is our starting accumulator. This right here. We started out with an empty array. It's similar to this line of code here, where we start out with an output. And we're passing it along as well. And we also have the number, which we take out of the array. And then we say this here, very similar to this one here. If that happens, and then we push it onto the accumulator, this one here that we're passing along. And yeah, by the time we get to the end, this accumulator has been filled up with all of the intersecting elements and then passed out. And we're going to move on to our very last one, which is our filter plus set. So basically, the set will take over this includes. So let's go ahead and get started. Function, intersection, and we'll call it a set. Pass it array1 and array2. How you initialize a set in JS is like this. So we can say let out, let's say let array2 set equal, we say new set, and inside we'll pass it the array that we want to turn into a set, array2, which basically gives every element inside of here a specific home that it is tied to, given it an O of 1 lookup time. Inside of an array, we don't know where each element lives if you don't have the index. So you have to look up with includes, which looks through every single element inside. But with set, we know the exact location of the value inside the set. And if it exists in there, it returns true. If it doesn't exist in there, it returns false when you look it up. All right. So we have this one, and then what we are going to do is just use the same filter method here. So I'm going to go ahead and copy this, put it here, and then we'll say return. Instead of this, we don't want to look at array2. We want to look at array2 set, and we don't use includes. We use the word has. So this word here includes, or this word has, is the same thing as this word includes, except it is specifically for sets. And this num is both the, the location and the value that we're looking up. To simplify it, this is not exactly how it works, but to simplify it for some of you who don't understand this, it's like saying that I have the value and the index are the same number, pretty much. But it's different. There's a hash number that is tied to. But yeah, you end up with an O of 1 time. And basically, we have the set that we created. This takes O of m times, which is the length of this to create. And then, because this is O of 1, this is O of n. This is just O of n times 1, which would be O of n. So we get O of n plus O of m. And yeah, pretty straightforward. Console.log, and we'll say, what are we doing? Intersection, and we're using our set. Here we'll go 2, 4, 9, and we don't have to do it in order for any of these. We can do 4, a 1, and a 10. So we're expecting to see in an output over here would be an array that includes 4 and 1. So let's go ahead and run it. We get a 4 and 1 over here. Yeah. So those are 4 different ways of solving this question here. Find the intersection of 2 arrays, which is just a way of saying find the elements that appear in both of these arrays. And So for our approaches 1 to 3, they all have the same time and space complexity. And for number 4, we decrease our time complexity, but we increase our space complexity. So it's a bit of a trade-off. Yeah. So there you go. If you have any more questions, post them down below. I'll try and help you out as much as I can. And I hope you learned something. Thank you.